So today we're going to start with the topic scalar triple product. Now, before starting, let us suppose that there are three vectors, that is A, B and C. Now, scalar triple product is just the scalar product of A and B cross C. So first of all, I started this one as there are three vectors A, B, C, right? Now scalar triple product is the scalar product of A and B cross C. Now triple means what? There are three vectors are in there. So A, B, C, there are three vectors. Now we need to get a product which has to be a scalar product, right? Now one thing I told you before, you should keep one thing in mind, that whenever you do a dot product, you will get a scalar quantity, and whenever you do a cross product, you will get a vector quantity, right? Now if I do scalar product of A and B cross C, so it will be what? Scalar product will be A dot B cross C, right? Now most of you would be thinking, why not A cross B dot C? Clear? I know you might, some of you will be thinking like this, but this one is not possible. Can you tell me why? The reason is that B dot C is not a vector quantity. We get a scalar. Now we cannot do cross product with a vector and a scalar, right? So this one is not possible. So it will be A dot B cross C. Understood? So this is how we express scalar triple product. Okay. Now it is denoted by it will be A, B, C. Look, the order has to be maintained. A, B, C. So it is denoted by A, B, C. Understood? So this is how we express scalar triple product. Okay? Now if somebody asks you what is B, C, A, I'm sorry. So it will be B dot C cross A. Clear? So that's our scalar triple product. Okay, now let's moving on to observations. Now let's do with our first observation what it says. Actually, we already know this thing. The first observation is we have B cross C. This is what? This one is a vector, right? So if I do A dot B cross C, this one will be a scalar. That is our first observation. Okay, it's simple as that. So A dot B cross C, the scalar triple product gives a scalar quantity. Okay. Now let's move on to the second observation. What it says. Now this is the most important one. So first let me write what is the observation, then I will move on to the explanation of it. Now it says magnitude of the scalar triple product is equal to volume of the parallelepiped, okay, formed by adjacent sides given by the vectors A, B and C. For the moment, just write this thing, then I will explain. So what it says, the magnitude of scalar triple product is equal to volume of the parallelepiped formed by the adjacent sides given by the vectors A, B and C. Understood? So this is what it says. Now magnitude of scalar triple product is what? We have already done magnitude. Now scalar triple product is what? This thing. A dot B cross C. Now magnitude of it is just write like this. Clear? Now let's see what is a parallelepiped. First thing first, let us see B cross C. Now how we get B cross C? First thing, we need to have a B and then C. Then we can get B cross C, right? So first, let's draw B. So here we have the B vector. Clear? Okay. Now let us draw a C vector. Let's make it here. So this is our C vector, right? Now we are doing cross product of B and C. So there is an angle theta in here. Understood? Now if I do cross product of B and C, can you tell me where will be the vector, where will be the direction of the vector of the cross product of B and C? It will be perpendicular to the plane in which B and C lies, right? So it will be, let us draw with this. So it will be in this direction, right? So this is the unit vector which is perpendicular to the plane of B and C. So this one will be the direction of the cross product of B and C. Clear? Now I know one thing. B cross C gives us what? The area of the parallelogram, right? Let's draw the parallelogram. Wait, we'll get to parallelepiped first. Slowly. Okay, now B cross C is done. This is the picture of B cross C. Now let us move on to A dot B cross C. Now we are doing dot product of A and B cross C. So let us have another vector in here. So this is our A vector. Okay, now if I am doing dot product of A and B cross C, can you tell me what will be the angle inclined by A, made by A with B cross C? It won't be this one. This is B cross C, right? So this will be the angle. Understood? Let us give that thing as phi. Clear? So now let's complete the diagram. So we'll have in here like this. I know it won't be perfect, but I will try my best to as much grasp the idea of it. So this figure formed is known as the parallelepiped, where are the adjacent sides are what? This is B, this is C, and this is A. This is what? A. This is what? B. This is again B. This is C, C, C. Clear? So this is the parallelepiped that is formed by A, B, C. Now how to find, what is the formula for the, we have to derive the formula for the volume, right? So let's do the derivation of the volume. Now first of all, you see volume of any, suppose what is the volume of a cuboid? It is actually what? It is area of the base. Volume of the cuboid is what? Area of the base multiplied the height. Yes or no? That's the volume of the cuboid, right? Now same here, the volume of the parallelepiped will be what? The area of the base multiplied by the perpendicular height, right? Now area of the base we already know. Let's just write volume of the required parallelepiped is equal to area of the base plus height, right? Now what is the area of the base? We already know. Plus, what am I doing? I'm sorry. It is area of the base multiplied with the height, right? Now let's find area of the base. So let's write just area of the base is equal to area of the parallelogram, and the area of the parallelogram is what? B cross C. Now is it just B cross C? No, it's magnitude of B cross C. Am I clear? Okay, now we have to find the height. Can anybody tell me what will be the height? The height of the parallelepiped is this one, right? This is the height. Am I clear? Yes or no? This is the height, right? Now how to find the height? It's very, very simple. We have discussed this one in one section. Okay, fine, I will give you a hint. We'll do it with the help of a projection. So can you tell me where? This is our A vector, right? I need the projection of A vector on B cross C. So if I project this one on this direction, so if I have like this, so this one gives our height of the parallelepiped, right? So what is that height of the parallelepiped? The height of the parallelepiped is given by the projection of A vector on B cross C, right? So let us find projection of A vector. Projection of A vector on B cross C. Who can tell me? Any idea? No. So the projection is given by, we have already done this one. It's A dot B cross C. I'm sorry about this. Divided by B cross. This is how we get projection, right? I hope you remember. If you forget, then I have nothing to do. Yes or no? This is how we do projection. Clear? So one thing, okay, A dot B cross C, it gives us magnitude, right? So let's just write this thing. So we will be dealing with magnitude. I will tell you the reason why we are writing the magnitude. So this is equal to what? Height of the parallelepiped is equal to A dot B cross C divided by B cross. Since we are dealing with height, so we will write the magnitude. Okay, it can be a negative value also, that's why I'm writing magnitude in here. Now can you tell me what was the volume we have? Therefore volume of, I don't want to write, I will write parallelepiped is equal to how much? A dot B cross C divided by B cross C and what was the, this was the height, right? And what was the magnitude of, where did it go? The area of the base, it is B cross C, right? Okay, so this one goes out. So what I have, A dot B cross C. That's it. This is our answer.